Hello everyone. I have made this presentation as a part of a refresher course which I am attending virtually at Bharathidasan University. In this talk, I'll talk about e-resources for teaching and learning of physics. So what are e-resources and where can we find them? So e-resources can come in several forms. They can be videos, books and other documents. They can be virtual laboratories such as general laboratories and computer laboratories. They can be demos and illustrations of theoretical ideas. They can be quizzes, games, and finally they can be journal articles talking about physics education research. So here are some of the sources where some of these things can be found, and some of the sources can be listed. So here there is a site which is maintained by MIT, which contains a lot of physics resources which I have found. Then there is this site which is by the American Association of Physics Teachers. Then there is another one by the Indian Association of Physics Teachers, and I'll talk about some things which are from the virtual labs initiative by the government of India. So I'll talk about videos from this Study Jams platform. Then I'll talk about some demos and illustrations taken from the physics classroom platform. I'll talk about some journal articles from the journal Physical Review Education Research, and finally I'll show some virtual lab experiments. So here is the thing that I got from the Study Jams platform. So here there is a video where a science teacher is talking to a football coach, and they look at some frozen puddle and they start talking about the phases of matter. They start with the gas phase where the molecules move the fastest, and then they talk about the temperature, and they mention that the gas is the phase where the temperature is the highest, and the football players or the molecules of the gas are running around the fastest. Then as we lower the temperature, the football players slow down and the molecules in the system slow down and the system becomes a liquid. Finally, if we cool it even further, everyone slows down a lot and then they turn into a solid. They talk about ideas such as condensation, which is the conversion from the gas phase to the liquid phase. Then they talk about the liquid to the gas transition, the evaporation, and they talk about what is the melting point, boiling point, and then they give a summary. Then in this platform they conduct a quiz to make sure that the people have understood the video, and here are the sample questions which they have. I'll just read out the first question. In which state of matter are the molecules moving the slowest? And then they have 4 options, and then they have 6 more questions like this, and if you answer all of them you get your final score and you can review your answers on the same platform. This platform is a very useful platform for many of the introductory physics ideas, and including the school level topics that we have in physics, and they have various topics listed in math and science, and some of the topics which are useful for physics classes are data analysis, measurement, probability taken from the math section, and from the science section they have solar system, force and motion, scientific inquiry, then matter, from which the video I just showed was taken, and energy, light and sound. Next I'll talk about the physics classroom platform. Here also there are a lot of menu options containing physics tutorials, physics interactive, multimedia studios and so on. They have concept builders, minds on physics, concept checkers, calculator pad, etc. And then they have curriculum corner, question bank and so on. And here I'll choose this particular item, which is the teacher toolkits, and I'll show you something which I found. So here there is a demo of a theoretical idea of standing waves, and here we can in this platform we can choose various options and look at the standing wave that is created, and we can also see that the standing wave is a sum of 2 traveling waves moving in opposite directions, which are shown in this blue dashed line and the orange dashed line. And here we have just switched to the higher harmonic, and that option is available here. As we click this, we can move to higher and higher harmonic. This is the next higher harmonic. To create this GIF image, I have used a screen to GIF app, which can also be used by physics teachers. The physics classroom platform has a lot of videos in their platform, and also they have a YouTube channel where all these videos are present and kept in various playlists. And here I have taken a screenshot of some of the videos I found. Next, let me talk about a journal which contains ideas which are useful for physics teachers. So this is the Physical Review Physics Education Research Journal, and here I'll just show some of the papers which I found. So for example, here there is a paper whose title is Insights into Teaching Quantum Mechanics in Secondary and Lower Undergraduate Education. It talks about various hurdles which we have while teaching quantum mechanics, and various things which people have tried and which are not so useful, and they give ideas of what we need to think about. Then there is another similar paper which is talking about written problem solutions and their application in introductory physics. And then there is another one which is the students' assessment of their learning achievement, perceived effectiveness of online recitations and online laboratories during the COVID pandemic and the lockdown, which forced all these things to be used extensively. And then one more idea in which we can use this journal very effectively is that we can search for whatever topic we are planning to teach or we teach regularly in that journal in Google Scholar by choosing the source as the journal, and whatever topic we can put that in quotes. So for example, if I search for statistical mechanics, I get some things like this: student understanding of Taylor series expansions in statistical mechanics, and also student understanding of the Boltzmann factor. These were obtained using this search. Next, I'll move on to this virtual labs platform, which is a platform where various institutes in India participate, including various IITs and Amrita University and some other institutes. So here from that lab, I found this experimental simulation where we have this Carey-Foster bridge simulation, where it starts with first checking whether the students have read the theoretical background which is necessary for doing the experiment, and then they can make their own circuit by choosing the various elements. And once the circuit is made, they can start taking readings. So at every point they have to choose the correct things, otherwise which makes sure that they have gone through the background theory material. And once the circuit is made, they can just start taking readings by choosing different values of this load resistance X. So this is a confirmation that the circuit is made correctly. And over here, this box here can be changed, and once this box is set to the correct value, they can choose this null point where the galvanometer here is perfectly vertical. And once they have that, they can note down this reading in the table given below. They can do this for other values of the resistance and complete the experiment. So I'll just show how the table looks after you take the readings. So these are the numbers which the students can put in these two boxes, and also after reversing the two resistances which are there in the circuit, and they have to take another set of readings. And once they complete these, they can do calculations of differences of these two values, which is automatically done on this platform. And I'll not go over to the other details of this experiment. So finally, to conclude, there is one limitation over here in the set of resources that are available for physics teachers, in that for slightly advanced topics in theoretical physics, and there is very little content available apart from very good classroom lectures and books and notes. There are not enough demos and other things for theoretical ideas. For experiments, to some extent, resources are available, so this is an opportunity where teachers can contribute. So thank you for your attention.